We're here at the bottom of page 3 in section 1.7. And we're back to what should be kind of a familiar type of problem now. Kind of see a pattern through every new topic we talk about. We end up doing the operation, then eventually we get to add the algebra, which is what we did at the top of the page, and then eventually we get to the point where we're involving some equations. And you'll see on page 4 what we also seem to do every time, and that is to do some translation, do some word problems with it. But let's stick here for a moment. Determine if the given number is a solution to the equation. So recall what that means is we're going to take that given number, the one that's outside the semicolon here, past the equation, and we're going to plug it in and see if it works, or see if it gives you a true statement. Okay, so a true statement means yes, it's a solution. A false statement means no, it's not a solution. So I go ahead, this is just my technique. You're going to find what works for you, how to show your own work so that the page really speaks to you. It really shows you what your brain is doing through the problem. As you get better and better at math and algebra, you should be able to condense your work and not show as much. But that's up to you. You have to then keep in mind it's not just about accomplishing the practice sets quickly. It's about being ready for the exam when you don't have notes to rely on and you don't have your book or your resource help, or someone you can ask. When it comes to the exam, you have to be able to do it yourself, and that means long-term memory. One of the best ways to get into long-term memory is to practice it over and over and over again. Okay, so here's what I do to kind of get it into place is what I'm doing. I rewrite the problem, and everywhere I see an x, I leave some workspace because I know I'm going to plug in that -3.5 as my x value here. So 16 minus 4 times x equals -2 times x plus 21. And I'm not even going to blink an eye at the fact that it's a mixed number. It's a fraction and a whole number, that it's negative. I can expect we're dealing with negatives here. That's what we've been dealing with the whole couple of sections. I know what to do just because the problem's getting a little bigger and I've got fractions. It doesn't change the fact that I'm going to plug these in. However, knowing what I know about fractions and knowing that when I plug them in here for x, I'm going to be multiplying first by a -4, then by a -2. I think I'm going to change this so that it's an improper fraction. This comes from experience. This is why I'm doing this example for you, so I can give you this heads up. I would convert -3.1/2 to -7/2, and I would use that instead. 2 times -3 is ignore the negative. 2 times 3 is 6. 6 plus 1 is 7. -7/2 is what we have here. So that's what I'm going to plug in each spot instead of the x, is -7/2. And then just as a reminder, subtraction is the same as adding the negative. So I really have 16 plus a -4, and I'm going to write that as 4/1 because I'm about to multiply these fractions together. Maybe I can highlight that just a little bit better. So I changed that to adding the negative here, and I also wrote it over 1, so I've got a fraction times a fraction, equals, again, -2/1 times -7/2. So what I did was I just kept the negative there with the 2, but I made the 2 as 2/1 because multiplying involving fractions means that you need to see top times top, bottom times bottom, numerators and denominators. Okay? And then I still have my plus 21. Order of operations says I need to do the multiplication first, then I can add in my pieces out here to the side. And just as a reminder, I'm just testing this. I'm just seeing if I get a true statement. If I don't, then -7/2 is not an answer to this problem. Alright, so what do we get here? 16 stays out here, 16 plus, I've got -4/1, -7/2. Those 2's are going to end up canceling here, and maybe I'll go ahead and rewrite that out a little bit. I've got some space. So I'm going to rewrite this as, I've got a negative here. The 4 is 2 times 2. For 2 here. The parentheses just mean multiplication. If it feels more comfortable, you could do it as a dot as well in between the two fractions. I also have negative 2 over 1. This one doesn't change any. There's nothing to factor here, but there is something to cancel once I do that. I've got a 2 on the top and a 2 on the bottom, which leaves me with 16 plus negative 2 on the top, negative 7. Negative 2 times negative 7 is a positive 14 over 1, or just 14, okay? And once again, I'm still just seeing if this is giving me a true statement. Will this equal what I have on the right side? And on the right side, let's make sure I didn't get that off kilter. Okay, on the right side, I've got the 2's cancel top and bottom. I've got a negative times a negative 7. That gives me a positive 7 over 1, or just 7, plus 21. So I actually skipped a little work there. So let me just talk through that again. I took my 4 over 1 and split the 4 into 2 times 2. Because I knew that 2 went into both, I'm going to cancel that. Some of you can do that in your head. You don't have to show this step. When the 2's cancel, top and bottom, I was left with negative 2 times negative 7 on the top, and basically 1 times 1 on the bottom. So negative 2 times a negative 7, negative times negative is a positive, positive 14 over 1, but that just becomes 14, okay? And then on the right-hand side here, I have negative 2 over 1 times negative 7 over 2, and I canceled the 2 top and bottom. And then what was left here, when you cancel that 2, you've got that negative still sitting there. So you've still got a negative 1. When you divide negative 2 by 2, you get negative 1, okay? It doesn't just disappear. When you get rid of a factor, you're leaving a 1 in its place. So this becomes negative 1 times negative 7, whole thing over 1 times 1. And a negative times negative is positive, so you get 1 times 7, which is 7. And the whole thing's over 1, so just 7. So I did a lot of work in my head. So if you have questions about that, I'll be happy to walk that through even more carefully and precisely in class. So I'm still seeing, does this give me a true statement? 16 and 14 is 30. Does that equal 7 plus 21, which is 28? No. So negative 3.5 is not a solution. This is a false statement. So no, negative 3.5 is not a solution. Let's try this next one. 7 minus z times the quantity 7 minus z plus 12z equals 0. So we're going to take our negative 5 and plug that in here. And we're just going to use it as negative 5. No fractions involved this time. Let's see what happens. So 5 times 7 minus z, and I'll just use brackets here. So I just know I'm going to put my z value in here, plus 12 times z equals 0. This is just my technique so that I don't drop negatives. That tends to be one of my biggest issues, even after all these years. So I know what my weaknesses are, therefore I compensate for them. I go ahead and give myself the little cushion, the safety net, so to speak. So I'm rewriting the whole problem, just leaving myself some space. What that forces me to do is that minus stays right there. And then I'm forced to put this entire piece, negative 5, inside of it. And then there's no dropping negatives. There's no, oh, well, is it just minus 5 or is it minus the negative 5? Well, the minus has to come down and then the negative 5 gets put in place. So there's no question. Both of those are present. And I'm trying to decide, does this equal 0? I just do that. Again, that's my technique to remind myself, what is it I'm doing? Okay, am I trying to solve? Am I trying to test? Am I just simplifying? In this case, I'm trying to test an answer, see if it works. Okay, so inside the brackets that I created, the brackets came from the fact that I put parentheses inside of parentheses. That gets a little messy, so we changed that outer layer to the brackets. It always goes parentheses, brackets, and if you need to, the little braces. I like to call them little French things. They're not really French. They just look extra fancy. Okay, inside. So I've still got my 5, and inside here I'm going to have subtracting a negative, which is the same as saying 7 plus the opposite, 7 plus a positive 5 here. So I'm subtracting the negative by making it adding the positive, adding the opposite. And then I still have my 12 times my negative 5, and we're wondering if that equals 0. Still inside the brackets here as our grouping symbol order of operations. 7 plus a positive 5, signs are the same, add them together, keep the sign, which is 12. So I've got 5 times positive 12 plus 12 times negative 5. Does this equal 0? 5 times 12, positive times positive, that's 60, plus positive times a negative, it's plus a positive 12 times a negative 5. When you don't see that sign in front, it's a plus. Okay, so we've got a positive times a negative here. That answer is going to be negative. 12 times 5 is 60 again. And I've got 60 plus a negative 60. Signs are opposite. I subtract. 60 minus 60 is 0. Or think of it as you're 60 to the right on the number line. You're about to go 60 to the left. That lands you back in 0. So I do get 0 equals 0. This is a true statement. That means yes. Negative 5. Oh, sorry about that noise there. Negative 5 is a solution to the equation. Okay, you get to try this one here at the bottom. Go ahead and hit pause and then come back. And it ends up that no, negative 9 is not a solution. And we'll go over the try problems thoroughly in class. All right, we're headed to page 4.